Okay, welcome to part 3. In this part, I'm going to start showing you some cool things that we can do with lights, such as getting them to blink on and off, as well as getting them to fade. And anything we do with lights, we can recreate with other systems such as motors. So it's pretty useful to know. Now, in order to get our lights to do cool things instead of just staying on, we're going to have to do a little bit of basic programming. Now, let me tell you that programming with Arduino is pretty straightforward once you get the hang of it, because it all follows the same rules, and there's only I don't know, like 10 or 15 really important commands, and if you know those commands and you use them correctly, it works every single time. So you want to open up the Arduino program on your computer, and it's going to look, kind of like this. It's going to have a weird, like, infinity sign symbol on it, kind of this color scheme. And when you open it up, you should have this application in front of you. But if you don't, just go to File, New, and create a new sketch. Now these are called sketches because back in the day when people used to program microcontrollers, they used to do it visually. It's like they would draw it out and they would plug in things. And now that we code things, even though it's not visual anymore, we still call it sketching. So for Arduino, we sketch things, even though it is a code. And there are two parts to the program. One called the void setup, which is things that are only going to happen once. So if I just wanted the light to go on or off, I could put it in here, and it would go on or off. And we also have the void loop, also known as things that you want to happen more than once. So if I wanted a light to go on and off a million times, I would put it in the void loop, because this is just going to cycle over and over and over again. And that's all been set up for us, so we just need to put our code in the right place, and it's going to work. These two dashed lines here, these are known as comment lines, and pretty much they're useful if you want to type things in that doesn't interfere with your code. So like I can type in anything, and if I ran this program, it would run just fine. But for now, and usually I just delete them, because I try to keep my code as clean as possible, and you want to make sure you get the syntax correct. If your syntax is off, you might run into issues later down the line. So anyway, we're going to plug in a light bulb, and we're going to do it very similar to how we did it before, except we're going to change one thing. We're going to plug in our ground into one of these negative ports. We're going to have our light bulb, and I'm going to clip this out so you can see the light bulb better, with the long leg maybe over here in port 15, and the short leg in port 11. And I'm going to draw out the light bulbs now with a triangle representation like this, and there's going to be two arrows coming off of it. And this is the LED notation. I decided to do it because of recommendation from a few of my first period students. So this just represents an LED now, the long leg and the short leg, and I'm also going to have a resistor going to ground. So I'm going to draw that with a pencil so we can get some resistance there. Now, you might be expecting me to use the 5 volts and just, running it through and then running it to the light bulb, but we're not going to run it through this power source, because this is literally the 5-volt source. It is just like raw power. We can't really control that power. We just get it all the time. And if we're trying to control lights, we have to control it by, fluctuating what it's getting, the power. If it's a high power or if it's a low power, like what exactly is this light bulb getting? So we're going to instead plug this end into port 9. And I could have used any port here, but I'm using 9 for a special reason, which I'm going to explain when the time is right. But I'm plugging that to 9, and you might be saying like, well, that's not 5 volts. How's it getting power? Well, fun fact, all these ports over here, they all get 5 volts. So it's the exact same thing as plugging it in here, except we can now control that source, which is useful because that's kind of what we want to do. So now that we have a closed loop, if you think about it, this is technically a closed loop, we can code something useful. So back in our program, I usually hit enter a few times and I create a variable. A variable is something where the computer can store in a value, because computers are innately stupid. Even though they can do all these amazing things, they don't remember information unless you store that information into a word, or pretty much a word, or a variable, which it's called. So in this case, I'm going to create a variable int called LED. And int just means that it's an integer. LED means that it's a light bulb, but I could have easily called it like cat if I wanted to. This is just a word. I can create any word I want for that. But I call it LED because we're working with an LED, and you want to keep your program easy to understand. And then I'm going to say it's equal to the port that it's plugged into. So since this is plugged into 9, I'm going to say int LED is equal to 9, and you have to close it off then with a semicolon. The semicolon is the most forgotten thing in programming. Most of the time, your errors are going to happen because you forgot to put one. So just be aware, after almost every single line of code, you have to put a semicolon. Okay, so we have our LED plugged into port 9. Now we have to specify whether it's an input or an output. So to do that, I would write this pin mode, and if you do it correctly, it's going to highlight. It's in a format known as camel case, meaning that the words after the first word always start with a capital letter. And if you do it wrong, your words aren't going to light up, and then your program won't work. It has to be in camel case. So pin mode, then LED, that's what we created up here. And then I'm going to write in all capital letters output, like that. And if you do it correctly, it will light up. If you did something wrong, it's going to stay black. So output, like that, and I'm going to close it off with a semicolon. What this is doing right here, this line is telling the computer that this LED is an output system. So whatever's plugged into port 9, that could have been like, I could have written 9 here because it's plugged into port 9, but I'm just going to use LED. Whoops. LED is an output. An output is anything that sends like information to the outside world. So an LED sends information to the outside world. A motor sends information to the outside world. An LCD screen would send information to the outside world. But things like buttons don't send information out, they take information in. So like a button or a photoresistor or a light sensor, those would all be considered inputs. And if I created one, I would say input over here. And based on what you call it depends, or pretty much dictates, how you can use it. So I'm going to just get rid of some of these spaces. Not a really big deal if you do or not, but yeah, pin mode LED is an output. So now that we have our LED established, we're going to get it to do some blinking. So to make a simple blinking code, all we need to do is write to port 9. Write to port 9. And there are right now two things we can do. One is we can power this up and send 5 volts, and the other thing is we can power it down and send 0 volts. If we send 0 volts, nothing's going to happen. If we send 5 volts, the light bulb's going to go on. When we send 5 volts, in Arduino, we call that high. That's a high power. So when we're referring to it in our code, we say high. When we want this to be turned off at 0 volts, we call that low. So the circuit has to be in one of these two states, high or low. If it's high, the light bulb goes on. If it's low, it goes off. So in our code, since it's digital, we're going to go digital, write in camel case, and then we're going to say LED, comma, high, close, semicolon. Take a look at how similar these two lines are. You're going to notice a lot of similarities in how we write things in this language. And like I said, it's once you get the hang of it, it's all pretty much the same deal. So we're going to turn on our light bulb, and then we're going to have a delay of 1000. And 1000 is in milliseconds. So this actually is just 1 second. If I wanted it to essentially delay for 3 seconds, I would do 3000. But what this means is it's going to do whatever's above it for this duration of time, and then it's going to move on to the next line. So the next line is going to be digital write, LED, low. And then we're going to delay that for 1000 milliseconds. So think about what this program does. It writes or turns on that port 9 LED, waits 1000 seconds, and then turns it off. Waits 1000 milliseconds. And then because it's in the void loop, it's going to loop over and over and over again until you unplug it. So go ahead, plug your Arduino in. To build your code, you want to first go to Tools, head over to your port, and make sure you have the right one plugged in. So it should say usually like Arduino, but if it doesn't, it should be like COM1 or COM2 or something. Click on that, and you only have to do that the very first time usually, and then from then on out, you press this arrow, and that's going to download the code into your Arduino board. So give it a try and see what happens. That's going to conclude this video. I'll see you in part 4.